everyone. Welcome to Parametric Planet and welcome to the part 2 of Etabs BHoM workflow. In today's video, I will show you how we can extract the analysis result from Etabs. So in the last video, I will just give you an overview. We have created our portal frame. Then we have created our adapter. And then we have converted these lines and bars into BHoM object. And then we have also created our steel sections, tapered steel sections. As you can see here, if I just remove this extrude view, these are our tapered steel sections. And now the first thing I will show you how we can extract our bars information. For that, we have to create this component pull. It will pull the results from the Etabs. So it's again, it needs adapter and the request which you want to do, pull type, action configuration, and Boolean toggle. So I will just copy this one, connect here, and this adapter. So the first thing we will extract the bars information. So for that, we need to create a request. So there are two options. Either we create a request from here, create request directly, or we can create a filter using create object, and then we can extract this information. So the first I will show you from the create object. If you right click, select an item, and if you go to data request, and then you have a bunch of request options like the filter. I will use the filter request. And then in the filter request, I will choose, there are different options, either a type or the dictionary type or the dictionary string tags. I will choose filter request, which needs type and the tag. So the type, I already show you how we can create the type. So if you go to the create type, right click, select an item, object modeling. And then if you go to structure, you have elements, and now you have bunch of options, like either you want to extract the bar FEA type, you want to extract the edges, FEA mesh, rigid link, opening, etc. So I will choose this bar. So when you connect this one with this one, so now it will only extract the bars or the elements, Etabs elements, which we have defined from the Etabs model. So you just connect this filter request with the request here, and then press this one to true. Okay, it's just the warning. And if you check in objects, so now we will have these 4 objects, and we have defined 4 elements in our model. So this is the information for the bar or the element. So if you want to see these bars in Rhino window, let's suppose if I hide these objects. Okay, we still have it. Doesn't matter. So I will just choose BHoM object, And if I just connect this one with the BoM object, now these objects are stored in this parameter. So if you click on this one, it will highlight. So now you have 4 BoM objects. And if you want to further see the properties associated with these BoM objects, you can go to the BoM and you can use this explode option. So now it will show you with this BoM object, we have associated properties like start node, end node, section property, orientation angle, releases. We have already defined these when we were defining the bar objects in BoM. Now, if let's suppose if I want to extract the properties of this element, you can use this option of item list item, I guess, list item, yes. And from here, you can choose your first object. So now it will show you the start and end node of this element. And if you further explore this one, it will give you the position, orientation, support, name, etc. And if you just see here, it will show you the BoM point. So it's now a BoM point. So if you want to store this one, just connect here. Now the point is in your Rhino window. And if you want to bake it, just simply bake this object. And now you can play around with this point. So that's how you can extract your bar information. So now we will create another pull request. In that one, we will extract the bar forces, like the moments, the shear force, and the axial force. So let me make this option false. I will just copy this one, remove this request. So there is another option. If we just press Shift Control B, then we have this option. And I want to create a bar forces. Is there any? No. So there is this type of bar forces. If we just copy this filter, bar forces, request, and now we have this error, bar force cannot be extracted using filter request. Please instead use of bar result request that give you more option for result extraction. So in this case, we will use this option of create request. So if I right click, I go to, again, I have this option of filter request. Let's see if we can directly create this request. Okay, we have this one, bar result request. So I will choose this option, bar result request. I will connect this one here. And let's see what options do we have. So now we have bar result type. We can request bar force, bar deformation, bar stress, strain, displacement, and mode shape. So for now, we will stick to bar force and division type. Let's see, what do we have? Okay, we have evenly distributed or the extreme value. Let's consider like we want evenly distributed forces. And then division, it says like how many points along the bars that result should be extracted. And then we have the cases, modes, objects ID. Let's stick to these options, and then after that we will explore these options, how these options works. So true, let's go to panel. So now we have bar forces. So it's a long list because it gives us the forces for each load case. If we want to check the further options, we can go and we can explore this element. So we have Fx, Fy, Fc, shear force, axial moment along XYZ direction, object ID, result case. So there are so many results. So let's see for which results case we are getting these results. So if I connect this one, then we have dead load, live load, and the model. So now it gives us the results for 3 types of load. So it means the first 3 items in this list are for the dead loads. It means at the start of the element, in the mid, and at the end of the element. So now if we just want to check for the dead load, so now we can select our case. So I can just select here dead. So I will only get the results for the dead load. And similarly, we haven't defined any live load or the model case. Even the dead load is the self-edge, so we will just stick to dead for now. And then now we are getting the results from all the elements. So if we want to extract the results for specific element, for example, for this column or this rafter, then we have to use the object ID. So if I show you here, the object ID is the unique name. So this is the object ID. So if I choose 2, then it will give me the forces for this rafter. So let's see. If I just select 2, so now I have only 3 items at the start, in the mid, at the end. And now let's check the value of for these load cases for different forces. In case of Fx, it's in Newton. So if I show you the result here, let's see. So the shear force is 1.3149 kilonewton at the start. This is the normal force. So this is the shear force, 1314.94 Newton. So in this case, we are getting in Newton. This is the start, this is in the middle, and this is at the end. So 1.3149, and then we have 0.5, and then we have 0.14. And similarly, if you check the moment, at the start we have 1942, then 257, then 677. And if we check the moment, it's 1.9421. And then in the middle, we have 0.25 and then 0.6775. Now we can also extract the nodal results, I mean the nodal reactions. So it's the same procedure. First, I will just copy this pull request. And now we have to create a request for nodal reaction. So if we just go to the create object, select an item, and if you go to the structures, then request, now we have the option here for the nodal result request. So we can choose any one of them. So I will choose the first one. Result type, access cases, modes. So I will just connect this one here. And for the result type, it needs which type, nodal reactions or displacement, etc. So let's just see what do we have here. It's a list. So as I said, nodal reactions, node displacement, velocity, acceleration, modal mass, etc. So we are interested in nodal reactions. So axis, it's same global. Case, we will select the same dead load for nodal reactions also. And let's see first, without giving any object IDs, make it true and just explode this one, panel, and we'll check the reaction. So it gives us the nodal reaction as we have 5 nodes, 1, 2, 3, 4, 5. So we have 5 items here. So this is the first one, this is the last one. So that's why we have reaction at the first node and the last node. So we will just filter this one. I will just select the last 2. It's going to be a first node and the 5th, and set to multi-data. Now we have this reaction value. Let's cross-check this one with our model. So yes, in our model, we have this value 2436 and 2409. 2436 and 2409. So that's how we can extract our nodal reactions. We can also extract the nodal displacements, and now we can check. We have in X direction translation, Y is inside, so it's 2D, so we don't have Y. In Z direction, we have at this location, and this location. Similarly, rotations. So that's how we can extract our nodal results. Guys must have noticed this point, like the nodal directions are not the same, like at this point and as this point, although our columns, they have the same length and the rafters have the same length. The reason behind this is the end length offset. So if you just check the extrude view, you can see that we have this end length offsets here. And that's the reason it's not equal. And there is a way we can adjust this one by modify these elements. So let's just do that. I will just delete this model. And before doing any modification, please remember to make it this thing false. This push option. So now we have option here to modify the objects as we did before when we wanted to flip our elements. So in this case, we would like to remove this end length offset. So if you go to this, select an item, and if you go to the adapters Etab, then we have this option of set auto length offsets. So Between these two options, the only difference is this option rigid zone factor. So that's the additional options which you can utilize by inserting or by writing some factor value for this option rigid zone factor. So for this case, I will just use this one. And this is a boolean. I will just make it false, and I will copy this one 4 times for 4 bars. This one here, and this one here. So let me just reconfirm. Yes, it's false. So I will connect this one with this one with this one, yeah, this one. So now let me push our model. So now if we see that end length offset is gone. So now we will just analyze this model and we will check the reactions. It's done. So now see, both reactions are equal. So it was because of the end length offsets. By the way, you have an option when we were selecting this bar element. So there you have an option to provide this end length offset. So if you go to select an item, and if you go to the structure elements bars, so in here, I think you have the options to create these offsets. So you can also provide these offsets, like you can provide some values 0.1, 0.2, 0.3.